So let's say that f is a given function, and let's say it's a continuous function and defined on some interval from a to b. So here's an example of such a function f. Because it's a continuous function, antiderivative does exist. So let's use this letter, maybe big F, and let's say that this is an antiderivative of the given function f. Then the definite integral from a to b of the given function f is simply f of b minus f of a. And this is the fundamental theorem of calculus, the second part of this theorem. Now the first part of this theorem gives us an explicit formula for this big function f, which is one antiderivative of the initially given function f. So here's an example. We'll be integrating the trigonometric function cosine. So the function f of x is the function cosine. One antiderivative of this function is the function sine x. So here's one antiderivative, and we'll use it to evaluate this definite integral. So we'll take this antiderivative, which is sine x in this example, and then we'll indicate that we want to evaluate this function when x is equal to 0, and then when x is equal to pi over 2. But first at pi over 2. So this is equal to sine of pi over 2, and then minus sine of 0. But we know that this is 1 and this is 0, so this definite integral is equal to 1. Here's a similar example. We'll take the function secant squared. So let f of x be the given function, which is secant squared. And then we'll take one antiderivative of this function. The big function f would be tangent x. And then we'll take this antiderivative to evaluate this definite integral. So we'll take this antiderivative, which is tangent x in this example, and then we'll indicate that we want to evaluate this function when x is equal to 0, and then when x is equal to pi over 4. First at pi over 4. So we'll take this function tangent and evaluate this function at pi over 4, and then minus we'll evaluate this function tangent at 0. But we know that this is 1 and this is 0, so the definite integral is going to be 1. It's easy to integrate the exponential function. So the function is the exponential function, then so is one of its antiderivative. The big function f would be the exponential function. So we can use it to evaluate this definite integral. We'll take the exponential function and we'll indicate that we want to evaluate this function at 0 and at 1. First at 1. So that's the exponential function at 1 minus e to the 0, which is 1. So this is equal to the constant e minus 1.